So we have R1 has got eBGP with R2, and R2, R3, and R1 are in same subnet. R2 may have another direct connection to R3 using some other subnet, but that's not revealed here. That's how the real world scenario goes. When we have this type of setup, R1 will see R3 as a next hop to reach 33, 33, 33, 33, though R3 is not an eBGP neighbor. R3 and R2 are IBGP neighbors. This is what we are going to see. BGP is clever to advertise the router 3's address as the next hop. The advertisement will be done by R2 without doing any additional configuration for that. BGP is clever to do that for us. Let's see this. On R1, this is the configuration. Neighbor 123.23.0.2. You see, I'm giving router 2's address. Remote AS is 23. From here also I want to advertise 1.1.1.1 mask. If it is classless, you have to match the mask with the interface mask and the write to memory. Right. Let me put this on R1. R1 is ready. I would like to verify before I go to the next router. Show IP BGP summary. This is the neighbor. So far that neighbor is not configured, so it is actively trying to reach the neighbor. And then show IP BGP. I'm asking what do you advertise? It says I'm advertising this 1111 network. Show IP interface brief. You can see that interface IP addresses rightly configured. Now let me finish R2. This is going to be 2 here, and BGP autonomous system is 23. And the router IP address is 1. And I want to advertise 2222 here. That's all.
And the remote AS should be 10, right?
Thank you. That's right. Remote AS need to be 10. And I also want to run OSPF on the loopback, so that router 2 and router 3 may learn this. Not necessary. It's okay. Let's leave it. We don't have any synchronization rule. Okay, so fair enough. Let's go to router 2. All right, now let's move on to the next router 3. Before 3, I would like to finish 4. Because soon after 3 we need to go for testing. Let's finish this 4. 4 is 123, so 134.34.0.4 BGP 40 and 134.34.0.3. Remote AS is 23. Network that I wish to advertise is here. Router 4. The next is router 3. Router 3 also got another loopback. Address on F01 is 3. This is 123.23.0.3, and that's all. BGP is
BGP 23.
23, and we got an IBGP. Okay, before that, let's finish eBGP, which is 40, and more important, we have IBGP. Did I configure IBGP on R2? Let me check once. Show IP BGP summary. No, let me put it here. Router BGP 123. What? Sorry, router BGP 23.
Oh, just 23.
23, and I have to say neighbor 123.23.0.3. Remote is the same 23. Okay. Now I'm on R3's configuration. R3 I have got eBGP with R4, which is done already. I would like to give manually the route ID. I don't want 33 to be taken as the route ID, so I want to give 3333. And then what else I have? I have another neighbor. One two three dot 23.0.2. Remote AS is 23. And the network I wish to advertise is 33. Oh,
Jay, Jay, if you go back, you should change the loopback interface to 1 for 33.
You're right. Let's put this on router 3. So after this, we will begin our testing. Now, router 4's network is unreachable for router 2. So we also need to say here next up self to router 2 address only. Router BGP 23 neighbor. This one 123. Yeah, this is the neighbor. I need to say next up self. And one more thing you need to know here is we don't have eBGP with R1. R3 has got eBGP only with R4. And we got IBGP with R2. And in R2, we need to say next up self so that the routes coming from R1 will be. No, I don't want to do that right now. We'll check it and then we'll do it later. If not necessary, actually. Sorry, that is not necessary because R3 knows how to reach the next stop, router 1. Okay, now let us move on to the verification side. First, I'm showing you the BGP summary. I can see here there are 3 prefixes learned. You know what are they? 2222, 33, 33, 33, 444. 3 prefixes. Show IP BGP. Look at this. This 33 is shown as if it is coming from router 3. The next stop is router 3. This is the smart move of BGP. Even though it is shown, all the networks are learned from this neighbor. 3 prefixes are learned from this neighbor, but the neighbor still manages to provide the right entrance ingress router's address. For router 1, going to router 3 straight away is the easiest, best way than going via router 2. Alright. But for the network given by router 2, it is still the same router 2's address. The other networks coming via router 3, even though router 3 is not a directly peered neighbor, we don't have any peering with router 3, but still we got the next stop of router 3. Let's try pinging. Ping 4 with the source of 101, the ping should happen. Which means R4 has also learned about 11111. And when you trace route, it should go straight to router 3. Not via router 2. Even though router 3 is not our EBGP neighbor, it's router 2.
Between R3 and R4, how does R3 know about R4's loopback IP?
We advertised from R4. We are not forming neighbor with loopback. We are forming neighbor with. Let me show you. Show IP BGP. Not necessary, no. See, I'm forming neighbor with the directly connected address. So no EBGP multi-hub, no update source. On R4, I have advertised that for network. That is this one prefix received. See, show IP BGP.
Okay, if we had a neighborship between R3's loopback and R4's loopback, we should have a static route.
We need a static route. We need EBGP multi-hop, and then update source.
Okay.
All right, fine. We'll